This is lesson 72, VHDL example 45. And in this example we'll implement a 4-bit shift register in VHDL. So here's the shift register that we had in the last example. We have data incoming in. And let's see how we can implement this in VHDL. The inputs will be clock, clear, and data in. We have the clock, clear, and data in. And the output will be Q3 down to 0. Q3, Q2, Q1, Q0. So those will be the outputs. And here's how we do it. We need to define a signal QS. QS is going to be Q3, Q2, Q1, Q0. We'll set Q to QS when we're done. So QS 3 down to 0 has to be a signal. Then we have a process, clock and clear in the sensitivity list. If clear equals 1, we'll do the asynchronous clear. QS is 0, 0, 0, 0. Else, on the rising edge of the clock tick event and clock equals 1, then Q3 gets data in. Q3 gets data in. And then QS2 down to 0 gets QS3 down to 1. So Q2 gets Q3, Q1 gets Q2, and Q0 gets Q1. So we can do all those three operations in this one statement. Now notice that it's essential that QS is a signal, because remember, signals don't get evaluated until the end of the process. We could not use variables here and have it work, because we first set QS3 to data in. But that's the data in at the beginning of the process. But then Q2 gets Q3. Well, we don't want it to get this Q3, that is data in. We want it to get the Q3 that we had at the beginning of the process, namely the old Q3. So Q2 gets the old Q3, and the new QS3 gets the data in. Same for Q2 gets the old Q3, Q1 gets the old Q2, Q0 gets the old Q1. So this only works if QS is a signal, because remember, signals don't get evaluated until the end of the process. Well, we can see that it works from this simulation. Here's the clock. Clear is our asynchronous clear. And we make some arbitrary data in. Here we made data in 1, then we had it 0 for a while, and then we had data in going 3 pulses. And you see that we have this shift register operation. So Q3 first gets data in on this rising edge, and then on the next rising edge, what used to be in Q3 goes to Q2, and on the next one, this bit which we brought into from data in ends up in Q1 and then in Q0, and then zeros get shifted in from data 0. And then we start new data zeros coming in, these 3 pulses, and you can see how these 3 pulses all get shifted through from Q3, Q2, Q1, Q0. So in fact, this simulation shows that this does behave as a shift register.